glaciers to deserts. Here we go. Welcome, Ignite students. Today, the desert. Okay. There's hot and dry. There's arid. There's hot and dry. There's semi-arid. There's coastal, and there's cold. We are going to focus on the hot and dry, maybe a little bit of the semi-arid. All right. Deserts depend. I've looked. There's several different definitions. Under 30, under maybe 50 centimeters of rain a year, so under a foot of rain a year. You should get an inch every time the rain comes through. So you get that in 12 weeks, right? I mean, you could easily get one rain a week and do that for 12 weeks, and then you've got it within 3 months, and they get that over the whole year, what you would get in 3 months. So it easily, very, very dry places. There's just not always one specific number that we're worried about. All right. Here we go. We're talking about weathering. Here we go. We got our hot and dry desert. You've got the Baja of Mexico. You've got Australia, and then you've got Arizona. The vegetation is very different than what we see, what we're used to, okay? Semi-arid desert, Red Rock Canyon. All right, Southern Nevada, Bridger, Montana. Here we go, sagebrush. So very different. And then Castle Valley in Utah. Sometimes the semi-arid, or even we'll get to later, the cold, it's about elevation. All right, the hot and dry is usually very, very low. Okay. Coastal, not something we're familiar with. The Atacama Desert of Chile is the coastal desert. Cold deserts, snow. Just doesn't snow a lot. Antarctica receives less than whatever it is a cold desert, right? So there are different ways to look at this. All right, here we go. The weathering. All right, so there's a picture of some weathered stones across the desert. Here's the thing. The chemical weathering is almost none. The mechanical weathering is everything. There is no water to do all of this, right? There's not enough water to do all this. So everything is sand blown, sand blasted, wind blasted. It's abraded. There's different words we're going to get into, but the water doesn't do its thing. There's over very, very long times, there can be chemical weathering. And you can get clay and you could get soil, but you'd need a lot of other conditions to be right. All right. So more examples of wind blowing and eroding. All right. Streams. An ephemeral stream. It's not ghostly. It's not, weird science. It's ephemeral is the opposite of perennial. Instead of running year round, an ephemeral stream, right after it rains, water flows in this little thing, and then when the rain stops, the water works its way downstream and then dries up. And the ephemeral stream stays dry. This might be, so you think shallow creek for our area that barely has any water in it in the fall. In the spring, it might have a little bit of water, and then it dries up, and you get this rocky creek bed. Okay, that's what it might look like around here. This is almost a wash. It's just a little valley. There's no water source at the top, but whenever it rains, all the rain from this area funnels down here and forms a stream. And then when that dries up, the stream goes away. That's an ephemeral stream. But that's what you have in deserts. There are washes, there are arroyos, there are basins out there where things run, where streams run. And you can see stream beds, but no water. Okay? These places can be extremely dangerous because when it rains, it's flash flooding and it's crazy how quick the water can come up and then it will go back down over a couple hours or days. Um, the other thing about deserts don't, or ephemeral streams, they don't have to drain into the sea. Every other stream in the world either goes to a lake or goes to a sea and it drains somewhere. You start up in the mountains and you work your way down to the coast. Deserts don't do that. The water flows for a little while and it's evaporating so fast, it's soaking into the ground so fast, it runs out of water before it gets anywhere, before it can erode downhill to a coast. So desert streams sometimes just have interior drainage. All right, they don't drain exterior. There's an arroyo, there's a dry a riverbed that can come up and down. This from the USGS was talking about the dangers of building near one and how it widened over the years. Uh, ah, so this is Sulphur Creek. All right, the water is flowing. The water is moving. That is not safe. All right. Um, one day later. Oh, sorry. Replay. That channel's barely flowing. Only one of the four pathways even has any water on it. Don't get me wrong. That's moving water. I would call that consistent. That's a creek. But look how smooth the water is by comparison and how turbulent it was the day before. That's the dangers of the flash flooding in the National Park Service. Let's see. Basin and range. All right. Basin and range is an interesting description of what's going on. There's like 200 small mountain ranges in our southwest up through the plateau, the Colorado Plateau. And they're interconnected, and there's this low area that separates these little bitty short ranges. And it's a different type of topography from lots of different spots on the earth. So some of the images here of the topography. Here we go. There's a basin range. It's not a good picture. It's not the one I liked. There. So you have the western limit, the eastern limit is so all of these separate mountain ranges going on, and then these dry basins down here. Oh, there's better images. So you have the Great Basin, and then you've got basin and range down here. That's decently colored. So the basin and range extends all the way through here. It's just a description of the type of land where you've got individual small dry mountains and then mountains and basins separating one another. All right. Now, what interior drainage? Yes. But if I've got this channel and I've got this valley and all of a sudden a flash flood happens. I said that wind is the driving factor in most desert. No, wind is not most desert erosion. Wind is more in the desert because the sand is light, and everywhere else the sand has plants and is water to stay down and doesn't get driven up into the wind. But even in the desert, with as little water as it has, water still drives erosion and weathering. And this alluvial fan, this is all of the sediment coming down the stream and then being deposited, because once it comes out of that narrow canyon, the velocity slows down and it drops all of the stuff it was carrying real fast. So there's an alluvial fan. There's two alluvial fans that have joined. There's one coming out. Right there's an alluvial fan. Let's see. There are a couple. So all of the rock, sediment, dirt that was in that stream, as soon as it comes out of the canyon, gets deposited. All right. I've got the Colorado River here. Colorado River up here in Grand Canyon, right? Down, 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 down through Lake Havasu, the reservoir, and out. Colorado River does drain out. I mention that because it's a rare thing that there is enough water coming in to not have it evaporate as it goes through this desert dry climate. The only other really big example of that is the Nile River. The Nile River is another river. It runs through a very, very arid region. So we did all the river things the other day, and the Nile just was very long, but it just didn't have a lot of volume. It's because it has zero tributaries. I learned that today. New fact. There we go. Zero other things of water come into the Nile. Where it starts is all the water it's going to have. So the fact that it makes that water makes it from there all the way to the sea without evaporating or without soaking into the desert makes it a rarity. It and the Colorado River are rare that they are rivers that start and run through desert and dry areas without becoming alluvial streams, without evaporating, without disappearing into the ground. That's all. All right. There we go. We got deflation and abrasion. There's abrasion. Where did our deflation go? Well, I lost one. Okay. Stick with me. So the wind's going to erode in the deserts. Two main ways it does that we're going to call deflation and abrasion. All right, deflation, you're going to lift the stuff up off, and you're going to lift anything loose up and off and carry it away in the wind. Deflation leaves these depressions. You can get these depressions called blowouts. They could be a meter deep and a couple meters wide, or they could be huge, kilometers wide. Blowouts where you're ripping up all the loose sand and silt on top until you get down to what's called desert pavement. And desert pavement, you know what? We're right here. We're online. Let's just do this. Desert pavement images is very hard and pebbly. Look, you see these exposed rocks because all the sand has been blown off of the top of it. The sand has been moved away. So what starts with a lot of sand mixed in reduces down to desert pavement. And it stays like that until someone walks on it, steps on it, or whatever. If you disturb the rocks, you can crush the rocks, break the rocks, and then you expose more sand and the sand gets eroded away. Over and over and over till you get this hard-packed desert sand, desert pavement. Saltation, you may have seen this little thing here. So this is the sand up in here. Saltation is medium sized particles that bounce along. They're not light enough to get blown around in the wind. They get up in the wind and then they come right back down and repeat. There are other particles that are even a little bigger that just kind of roll along the ground and creep. So blown in the sand, blown in the wind, saltation, and creep are ways to move things. Abrasion, lots of cool abrasion things. Let's look here first. These rocks are abraded. You can see scars where in all one direction where the wind continually sandblasts these over and over and over. The other thing, you can get these weird formations. The sandblast rock, but if this rock is not uniform in what it's made of, then the sand's going to take away the less dense rock, the softer rock first. The other thing, the wind is stronger right here, right on the surface level, and that's why you get more erosion at the bottom in some of these things. All right. Let's see. All right. So the wind can move all these things away, but the wind is now going to carry this stuff, and it's going to carry it somewhere. The terms you're going to hear are a lot like stream terms because the stuff's going to fall out at different places. Lois is what falls out everywhere. Lois is silt. All right. Lois is windblown silt blanketing the landscape because there's a little bit everywhere. Is small amounts of this fall out everywhere, all across. This is western and northwestern China. This is the Midwest, and what you see is lots and lots of good, fertile silt soil. Why do they farm it in terraces in different spots? Why is this asking you to farm it in terraces? Is because this silt, if you farmed up and down or even across, it's going to erode down the hill so fast you're going to lose all the fertility in this upper region. So they farm it in terraces. All right. These Loises, Loess, by the way, these are categorized different types of soil when they were deposited, because this is long term. It's not something you're going to notice. All right. It's deposited over years and years and millennia. It's not the bluff. Some of these are exposed. You see it because there was a cutting or a road or there's a bluff that you see it. But all of this is just silt soil that's been blown in across the upper Midwest. It was blown from the last ice age. As the glacier retreated and you've got all this silt, it's blown across the Midwest. All right. And since we said that there's some in China, this is the same. This is the blown silt. All right. Now, how does that contrast with a sand dune? Because the wind has sand in it, but the sand is very, very light, and the sand is going to go with the wind until the wind slows down. So if you have one little obstruction, the wind is going to slow down. It's going to drop some of the sand. And now that you've got a small pile of sand, this obstruction is bigger, and the wind's going to slow down and it's going to drop more. And once the pile of sand becomes big enough, it becomes its own obstruction, and you're going to build a sand dune out of this. Okay. So instead of being even and blanketed over big, broad areas, sand dunes are concentrated, and they need an obstruction. All right. The sheltered side is steeper and a sand dune, but in the top keeps falling over, and you get these layers on the backside. Those layers, if you add more and more and you wait millennia, those layers will compress into sedimentary rock or maybe specifically sandstone. And those layers will be preserved in that. All right, but let's look here. Let's look. These are something very familiar to all Missourians. No, not even close. Okay, the first one, top left here. This is a bracken, okay? Barchan. It's solitary. All these dunes are by themselves. They're alone. They're crescent shaped. The wind is blowing that direction. All right, so here's the gentle side. Then you've got a steep side on the back. To have this, you need flat, hard ground, and you need not a lot of sand availability. All right, this one, transverse, because these lines and the dunes are perpendicular. They're transverse to the direction of the wind, okay? You need steady winds and lots of sand to make this. Sometimes these are coastal, but this is what you would see the sand seas in the Sahara and the Arabian desert. That's a transverse sand dune. This brackenoid is halfway between these two. So you've got the lines of transverse and a steady wind, but you're starting to get individual crescents and scallops built in there. White sands in New Mexico are a good example of this. All right. Longitudinal. So if this is transverse, this is longitudinal. Longitudinal means that these lines are going to go with the wind. You need moderate sand and slight, maybe a variable wind. It's going to change a little bit. Sometimes it's this way, sometimes it's this way. So it's going to, but overall, it's that direction. So it's going to pile them up into these ridges. Parabolic. Parabolic is the opposite of the Barchan one, the Barcan one. shape is almost backwards. You got to be coastal. You need some vegetation, and the vegetation covers some of the sand. All right, it's crescent. You need onshore winds and lots of sand to build up these. All right, so those are the parabolic ones. Star. Okay, these are isolated hills. Sometimes you've got 1, 2, 3 ridges coming off. Up here, you've got 4 ridges coming off of there. Okay, parts of the Sahara, parts of the Arabian Desert, sharp ridges. You need lots of variable winds. The winds are always changing. Okay, that is deserts. There's a lot going on. That's deserts. Have a great